Now we're going to be talking about how to perform XY2-100 and FB4 communications, which are standard in our industry. For doing that, some of our clients will like to use low-level embedded systems such as like Arduinos or Raspberry Pis. So we have taken here and we have implemented this type of communication protocol into Arduino. In this case, we're using a Porpenta C33, and this is the one that we're going to be using to demonstrate this specific protocol. You can also follow our manual that you can encounter in the Arduino folder for our Github. You can see the manual where this is explained, not just how to do the electrical connections, but also all the bit level logic that you need to understand in order to program this for FB4 and XY2-100. So if you see also in our folder, you will see that there is different type of example. There is the FB4, and for XY2-100 we have two examples, one for 16 bits and one for 18 bits. As if you read our Mach-DSP manual, you can see that our Mach-DSP is designed to handle both of these protocols. So let's do an example right now. We are running the XY2-100 of 18 bits. So let's take a look at that code. As you see here, obviously this is Arduino environment. We don't have here like a fancy GUI like with the Python or LabVIEW, but you can Arduino code is very friendly and intuitive to understand. So first, we define here our pinouts. We define the packet length. This will depend of the serial communication. And here, obviously, we can define the frequency and amplitude of waveforms. This is all explained in the documentation manual. You have different type of waveforms that you can select between sine wave, square wave, triangle, and sawtooth. So you can independently set each one for each axis. So you can put any type of waveform in the x-axis and any type of waveform in the y-axis. If we go down here in the setup, you will see that these waveforms are pre-computed before we stream them. That is because when you're dealing with low-level hardware, you would like to everything is related to speed. So you would like to pre-compute these waveforms and stream them in your void loop point by point. So here, if you go down in the loop, you can see here is where we do all the bitwise operations to do our protocol. For example, if you see our manual, you will see that, for example, for XY200, depending of, and let me zoom up. So depending of what type of communication protocol you use between the 18 of the 16 bit, you will see that you have your data. If you do the 18 bits, you have 18 bits of data plus one extra bit, which is the C2 value. All of these can be encountered, and all this theory is explained in our documentation manual. So this is to prove you that you can guys do XY200 and FB4 communication protocols using an Arduino, and you can find examples for all of these in our GitHub.